Okay. The last part is optimal power flow. So what is the difference between optimal power flow and B coefficient based economic dispatch? What is the difference between optimal power flow and B coefficient based economic dispatch? What?
Sir, approx
B coefficient is an approximate one, whereas in optimal power flow we use directly the load flow output of the losses. Okay. So in the economic dispatch we had single constant which held the total generation equal to load plus losses, equality constant. If you think about single generation equals load plus losses constant, we realize that what it is actually saying is that generation must obey same condition as expressed in a power flow. Okay. So basically we mean this, the same conditions in a power flow. OPF formulation results when these constants are entire set of equations needed for power flow constant. So this line you write. So the OPF formulation, what is the OPF formulation and economic dispatch formulation difference? Write down this. OPF formulation results. OPF formulation results when the constants are entire set of equations needed for power flow as constants. Okay. The difference is that in OPF the objective function may not be only minimization of cost. Okay. In OPF it can be minimization of electrical losses, minimum shift in the generation, and minimum load shedding schedule, etc. Okay. Regardless of the objective function, the OPF ensures that the set of power constants are present and satisfied. That means the speciality of OPF is that it always satisfies the load flow equations. It always satisfies the load flow equations irrespective of whatever is the objective. Okay. So this is a typical formulation of the OPF. So the aim of the OPF problem is to obtain a power flow solution which optimally satisfies the stated objectives subject to the system constants. Okay. The objectives of OPF are operational features of the power system. So if somebody asks you, in suppose some job interview you are going PGCIL, you have cleared that exam and you are attending the interview, they will ask you what is, because PGCIL or PSOC they use OPF as the base. After that the planning happens. So they will ask you what is the objective of OPF. So the one you should remember now should be there in your mind till that day. What is OPF? Operational features of the power system. That is our objective. To optimize the operational features of the power system. Maybe loss, cost, whatever. Generation shift, transformer shift. Okay. Now basically these are minimum cost, minimum emission or multi-objective based. So we write that in terms of this. Okay, write down this equation only. So I have written only two objectives. It can be multiple objectives. But the constants are of two types. So that you mentioned there. GPI equals to 0 means this is a G is equality constant. H is an inequality constant. Okay. So you have two sets of constant, equality constant and the inequality constant is written in general form like this. Okay. Here it is written where GI, PI and HI, PI are equality and inequality constants. Now these are some constants. For example, equality you know. Okay, summation power generation should be equal to demand plus losses. Inequality constants are just like several. One is minimum maximum limit of the generator that we have just seen. Or load flow. S means load flow. The power flow in the transmission line should be below the limits of the transmission line. Rating of the transmission. I am not talking about thermal rating. Maybe even the stability limit of the transmission line. Okay. And the voltage deviation at different parts of the transmission system should be within limits. We have a limit. So all these limits can be imposed. Okay. So what are the variables? So in this particular, see I have shown you only one formulation of the OPF. OPF can have multiple types of formulations. So in this case we have fuel cost, emission, number of thermal generators, real power output, cost coefficients, okay, emission characteristics, equality, inequality and so on. Okay, SL is the total power transfer through the transmission. So this is all about the formulation of the OPF. Now why we go for OPF? What is the requirement of OPF? Now as I class 2-3 classes, representation of incremental losses is exact because it is obtained from the load. It's exact, not approximate. Okay. In addition to generation limits of economic dispatch, OPF includes other power system limits such as limits on reactive power, limits on voltage magnitude, flows on the transmission line, MVA, megawatt or MVA. Okay. This set of operating points ensure that the dispatch of generation does not force the transmission system into violating a limit. So OPF ensures that the transmission system is not violating the OPF is the basic tool that is used by all power system operators. It is used practically. They have their own programs. That's a different thing. Different vendors, different programs. Another kind of OPF known as security constants OPF can include constants that represent operation of the system across contingency outages. OPF forces the system to be operated so that the contingency has happened, resulting voltage and flow to the limit. What is the contingency? What is the meaning of contingency? What's the contingency? What contingency can happen for your GATE exam? What contingency you may face? You may fail to wake up in the morning. Your bike may fail when you are traveling. So these are known as contingency. It don't happen, nothing happens. But contingency means some kind of fault. Okay. So whenever a fault happens in the power system, the OPF ensures that after the fault is cleared, all the variables are within limits. OPF would prevent post-contingency voltage after the fault. Okay. In economic dispatch calculations, the only adjustable variables were generator megawatt output. That you have seen, only generation we are controlling. But in OPF, we have got several such variables. Generator voltage, transformer tap position, phase shift transformer tap position, switch capacitor ratings, reactive injection, load setting, and DC line flow. The ability to use different objective functions provides a very flexible analytical tool, which is OPF. Okay. So what are the applications of OPF? Basically, in power system, by authorities such as OPDCL, PGCIL, all these organizations, they use OPF. But for what? Computation of optimal generation pattern as well as all control variables together with meeting the transmission system impedance. For example, OPDCL will do a OPF and ask hydro power plant, okay, this is the generation schedule for you for next this much hours. Okay, so after doing OPF. Using the current state of the power system or a short-term load forecast, OPF can be set up to provide a preventive dispatch if security constants are incorporated. Okay. In an emergency, when some components are overloaded, OPF can provide a corrective dispatch. It may remove generation from some power flow from some transmission line which is overloaded. Okay. Corrective and preventive dispatch. The OPF can be used periodically to find optimum setting of generators, transformer taps, switch capacitors, and static Hall compensators, which are known as FACTS devices, flexible AC transmission systems. The OPF is routinely used in planning studies, always. Okay, OPF is the first place, and also OPF can be used for providing many other things like bus incremental costs. Okay, so with this we complete.